Hey guys, Happy New Year. I hope everybody had a healthy, happy break. Unfortunately, I'm not able to be back in school until Thursday. So I figured that I would try to record some lessons for you guys to watch and see if you can pick up the material, which I think you guys can. So today's lesson is going to be on dilations and scale drawings. So you're going to need a compass. So if you guys want to take out a compass and a straight edge. Okay, so what is a dilation? So a dilation is a transformation that enlarges or reduces a figure proportionally. Okay, so since it enlarges, makes it bigger, or reduces, makes it smaller, proportionally, a dilation produces a similar figure. Okay, so that's why this is still part of our unit on similarity. So if the figures are similar, we know corresponding angles are congruent, corresponding sides are in proportion, and parallel. Okay, and a dilation is performed with respect to a fixed point, and we call that the center of dilation. Okay. Okay, so here we're going to actually perform a dilation. So in this first example, it says create a scale drawing to the figure below using the ratio method about center O. Okay, so center O is the center of dilation. And we're dilating by a scale factor of 3. So that means that we're going to produce a figure that's 3 times the size of the original. Okay, so the first thing you're going to do in this construction is you're going to take your straight edge and we're going to connect the center to each vertex and draw a nice long line. So I'm going to connect O to C, O to D, O to B, O to A. Okay, so that's the first step. So again, we take the center and we connect it to each vertex, and we're going to draw a line nice and long. Okay, so now we're going to take our compass, and I'm going to dilate point A first. And again, our scale factor is 3. So we're producing a figure that's 3 times the size of the original. So what I'm going to do is I'm going to put the middle point of my compass at my center of dilation. So middle point at O. And then I'm going to put the pencil at A. So when I adjust my compass and I measure from O to A, that's a scale factor of 1. So I'm going to draw a little arc, right? So that demonstrates to the person grading your paper that you measured from O to A. So that's a scale factor of 1. So then I'm going to go to A, and I'm going to mark that arc again. So that's a scale factor of 2. And then this gives me a scale factor of 3. Okay? And then I'm going to do the same exact thing for the other 3 points. Okay, so I'm going to put the metal point to my compass at O, place my pencil at vertex B, whoops. Okay, so when I measure from O to B, that's a scale factor of 1. So I'm going to move up. That's a scale factor of 2. Move up again. That's a scale factor of 3. Okay, next I'm going to do point C. Okay, so again, I measure from O to C, scale factor of 1, 2, 3, and then I'm going to do the last point D. So metal point at the center of dilation, pencil goes to point D, so that's a scale factor of 1, scale factor of 2, sorry, and a scale factor of 3. Okay. So this point right here, we're going to call this A prime. This point here, we're going to call B prime. This point here is C prime. And this point here is D prime. Okay, so now I'm going to go back, take my straight edge, and I'm going to connect those points the same way the original figure is connected. So A prime to B prime, B prime to C prime, C prime to D prime, and A prime to D prime. Okay, so you notice that the figure is 3 times the size of the original. Okay, and they appear to be the same shape and the corresponding sides are in proportion. Okay, so just a little bit of vocab. The original figure, so figure ABCD, is what we call the pre-image. And then A prime, B prime, C prime, D prime is called the image. Okay, so pre-image is like what you start with, or the before, and then the image is the finished product. All right, and that's a dilation with a scale factor of 3. So this is what I call a stretch because the figure got bigger, okay? All right, so now if we take a look at the next example, here we want to dilate about center O, so O is our center of dilation, but now we want to use a scale factor of 1/2, okay? So now this is going to be a shrink, meaning that the image is going to be smaller than the pre-image. Okay, so we're still going to start out the same way. I'm going to take my straight edge, and I'm going to connect the center to each vertex. Okay, and in this example, it's not wrong if you extend those lines, but you technically don't have to, because we know that our image is going to be smaller than the original. Okay, sorry guys, just bear with me. I'm using a computer mouse as I do this, so. Okay, So when you want to dilate by a scale factor of 1/2, we're going to be using a bisector, all right? Because a bisector, we know, intersects the segment at its midpoint, and the midpoint is the halfway mark. All right, so what we're going to do here is we're going to put middle point at the center of dilation, just as we did before. So again, when you measure from O to B, that's a scale factor of 1. Here we want a scale factor of 1/2. So we're going to use a bisector to get our halfway mark, or our midpoint. Okay, so this point right here is B prime, okay? And then you're going to do the same thing with OA and OC, all right? So, whoops. Okay, so middle point at O. Make sure you extend more than halfway. And now I'm going to bisect OA. Okay, so that point's A prime. And then we're going to do the same thing with OC. Okay, so again, make sure you're more than halfway. Swing that arc above and below. Turn it around, do the same thing on the other side. So this point right here is C prime. Okay, so if we connect, oops, that was supposed to be a different color. Okay, so if we connect A prime to B prime and C prime, you should get a triangle that's half the size of the original. Okay, so that's dilating by a scale factor of 1/2. So if I asked you guys to dilate by something by a scale factor of, let's say, 1/4, then you would have to do a second segment bisector. Okay?